Okay, we will be starting now. Hello, everyone, and good morning. Dear authors and invited guests, welcome to Technical Session 5A. My name is Dimahi Patel, and I'm the moderator for this session. On behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you to the 10th International Conference on Information and Communication Technology for Competitive Strategies, Jaipur, India. The 10th edition of the conference is being organized in a hybrid mode. The physical event was held yesterday in Jaipur, and the virtual event is being held through Zoom today and tomorrow, that is 16th and 17th December 2025. I hope you will enjoy the knowledgeable and interactive sessions through the day. In this session, we have 10 presentations. Each presenter will be given 10 minutes for the presentation and 2 minutes for question and answers. On 9 minutes, we will raise a gentle reminder. There is another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in the chat box. Before we continue, I would like to introduce you all to the chair of the session. We have with us Dr. Kirit Modi. Dr. Kirit is the Dean, Professor, and Head at Sankalchand Patel University, Gujarat. With over 25 years of teaching experience, he has published more than 25 research papers in reputed journals, conferences, and his expertise spans artificial intelligence, cybersecurity, cloud computing, IoT, edge computing, and big data analytics. We welcome you, sir, and I invite you to share a few words you have for the presenters today. I repeat, Kirit Kumar, sir.
Hello.
Yes, sir. Welcome, sir. Sir, if you have any words to share, please let us know, or else we may continue with the presentations. All right, we will be starting with the presentations then.
Yeah. Please.
Yes, sir. I would like to call Soham Rathod to present his study on a machine learning based framework for detection and mitigation of DDoS attacks in cloud environments. Soham Rathod?
Yes, ma'am.
Yes, sir. Please start with the presentation.
Okay, ma'am. So, good morning, everyone. My name is Om Rathod, and I'm presenting my research paper. My paper ID number is 107. It is a machine learning based DDoS attack, a machine learning based framework for detecting and mitigation of DDoS attack in cloud environment. So, this work was conducted in collaboration with my another teammate, Twinkle Solanki, and my mentor, Dr. Sneha Padhyar at LDAP Institute of Tech and Research. Our primary focus is solving the latency and cost issues associated with protecting cloud infrastructure from DDoS attacks. Uh, so let's start with the problem. Cloud adaptation is rapid, but it introduces a specific vulnerability called EDOS, which is economical denial of sustainability. When a DDoS attack hits a cloud environment, it doesn't just crash the server, it triggers auto scaling rules. So the system spins up more resources to handle the fake traffic, leading to massive and unnecessary operational cost. Furthermore, in a shared cloud environment, if one tenant is attacked, then the shared resources can degrade performance for other legitimate users. The financial impact is often more damaging than the service outage itself. Why aren't the solutions enough? So for that, we identified three critical gaps. The first one is signature based failure. Traditional IDS relies on known signatures, but they fail completely against zero day attacks or novel patterns. The second issue is latency. Deep learning models like complex CNN are accurate but computationally heavy. In a real time attack, you cannot afford high inference time. Delayed detection means higher costs. And the third issue is mitigation. AI systems are smart, but requires human intervention to update firewalls. By the time a human, the damage is already done. So, to address this, proposed a hybrid framework, integrated lightweight machine learning models, specifically like random forest, SVM, and LSTM, directly with cloud native tools like AWS Web Application Firewall and Lambda. Our key contribution is the automation loop. We successfully reduce the mitigation response time to under 3 seconds and demonstrated a 35% reduction in operational cost during active attacks. Data sets. Data quality defines model accuracy. So we use the CIC DDoS 2019 dataset from the University of New Brunswick, which provides a realistic mix of benign traffic and modern DDoS attacks like TCP, UDP, and HTTP floods. From the raw traffic, we extracted 49 numerical features. The most critical ones of our detection engines were: the first is source IP entropy to measure the randomness of IP addresses. Second is packet rate and burstiness to detect volumetric anomalies. And the third is TCP flags and inter-packet intervals to identify behavioral pattern such as SYN flood where the handshake is never complete. For methodology, we implemented and compared three distinct supervised learning models. As I mentioned earlier, the first one is random forest. We choose this for its interpretability and speed. It handles mixed data types well and is less prone to overfitting. Second one is super vector machine, SVM. This was effective for high dimensional feature spaces, though slightly more computationally expensive. The third is LSTM, long short-term memory, a recurrent neural network used to capture the temporal relationship between packet sequences, essentially understanding the context of traffic over time. These models were deployed as microservices using Flask to allow for scalable inferences. This is the proposed architecture. Please look at the architecture diagram on the slide. First is ingestion step, where raw traffic enters the cloud environment. Then it goes into pre-processing step. We use tools like Wireshark or Zeek Logic to capture packets and extract the features I mentioned earlier. Then the data goes into inference engine. The traffic data is passed to our ML models and then to the decision model. If it detects or flags traffic as a DDoS, then it triggers the mitigation module. This entire pipeline sits within a simulated AWS environment, utilizing EC2 for compute and S3 for logging attack data for further retraining. Automation. This is the most critical part of our framework, the response. Once an attack is detected, the system triggers an AWS Lambda function. This function executes a script that immediately updates the AWS Web Application Firewall rules to blacklist the malicious source IPs. Simultaneously, the elastic load balance reroutes legitimate traffics to healthy instances to maintain service availability. The total time from detecting to rule update is approximately 2.9 seconds. This speed is what prevents the cost spikes associated with autoscaling. As for the evaluation result, it is presented in the table. First is random forest, which was the top performer. It achieved 97.5% accuracy with the fastest detection time of 1.2 seconds. SVM and LSTM were also highly accurate with 95.8% and 93.2% respectively, but was slightly slower or more source intensive. Crucially, in our simulation, the random forest integration results in a 32 to 35% cost reduction compared to a system relying solely on standard auto scaling without machine learning mitigation. As for the conclusion, our hybrid machine learning framework proves that integrating lightweight models like random forest with cloud native automation is a viable solution for mitigating EDOS and DDoS attacks. We achieved high accuracy, low false positive, and significant cost savings. For further work, we plan to test this framework against encrypted traffics like HTTPS without decrypting it and explore federal learning to allow different cloud tenants to share attack intelligence without sharing privacy data. Thank you, everyone.
Great, sir. Any questions?
Okay, so just I would like to ask you about what exactly the use case you are considering. For what kind of the scenario you are actually developing or designing this framework?
Sir, current DDoS attacks are in current scenario, DDoS attacks are very powerful, and within the time it is mitigated, or we can say detected, the cost of the uh, so basically, the cost increases on the companies, or we can say cloud, until the time a DDoS attack is detected or it is mitigated. So we are planning to reduce the time of detection and mitigation.
Okay, fine. Yeah.
Okay, thank you, sir. Now, next, I would like to call Gaurang Mishra to present a study on a review of jailbreaking large language models, methods, challenges, and defenses.
Yes, ma'am. Is it visible, ma'am?
Yes, sir.
So, good afternoon, everyone. I am Gaurang Mishra, along with Dr. Shikha Maheshwari from Manipal University, Jaipur, presenting our paper, A Review of Jailbreaking Large Language Models, Methods, Challenges, and Defenses. This is the outline of my today's PPT. So let's start with introduction. So first we understand what is LLM. So the large language models is a deep learning model trained on massive data set that can understand and generate human-like text. Models such as GPT, Bard, Gemini we use in our daily life that generates a natural looking text in multiple domains and applications. And we are utilizing these applications in multiple fields like finance, health, education, corporate, banking structures. So why this is a security risk? So AI and LLM we know is a rapid getting integration in critical sectors like healthcare, finance, education, and expand this integration with different sectors expand the attack surfaces. If we look at the diagram on the screen, you can see where these model fits. They sit within generative AI, which is a subset of deep learning, and they are now used and integrated in almost all domains and sectors like finance, education, health, and etc. They access all the data resources, and this is what make it a concern to look for. And when machine is trained on the data sets, if we provide the deceptive inputs, and which is known as the adversarial machine learning, it aims to take these LLM models to produce some harmful outputs or to get some serious privacy and security issue. So in the real world scenarios, nowadays we are working with GPTs, Bard, Gemini. So in real world scenarios, these adversarial attack take form of a prompt injection called jailbreaking. Let's understand what is jailbreaking. So jailbreaking refers to crafting adversarial prompts that manipulates these LLM models to generate some responses which are not ethically standardized and which is against our user policies and shows the harmful behavior or content generation. These are the risks associated with jailbreak. First is malicious content generation. It writes some phishing scripts for the hackers or creates some malware code or generate some malware kind of scripts. Second is the data privacy. It can extract and leak some sensitive information, as all users are nowadays working with GPTs and BARD, and they are uploading their files and information to the AI and models. So data privacy is also a concern. Third one is misinformation. So we can write some news articles, some political based articles, or some gossiping articles which impacts the public decision, and it can spread false information in the public. And the fourth one is cybersecurity. Attackers and fraudsters can use these AI based models for generating some kind of fraud activities, tips and tricks to attempt these LLM models. Also, they can get data from these LLM models, which is used by publicly nowadays. So what is the motivation behind this research and study is, first, everyday adoption is LLMs are integrated in everywhere, like health and education. These models now writing our code and diagnosing patients, handling financial data. And second is the attacks are evolving. So we are shifting from the earlier what is having is manual. We have some manual tricks to bypass these model filters and use the jailbreaking systems to manipulate these models. But nowadays we are shifting from manual attacks to automated frameworks attack like easy jailbreak framework. So this is the major issue. We need to focus on these type of attacks on LLMs and AI. What our contribution is, this paper provides a dedicated review specifically on jailbreak attacks. Jailbreak attacks is a kind of adversarial attack, but all the current studies we have verified and we have done a case study on the papers we have reviewed. So all the papers are mostly dedicated for the adversarial attack, none for the jailbreaking attack. So we dedicated our review specifically for the jailbreak attack and analyzes what the unique mechanism the developers or the hackers are using to bypass these filters and manipulate the models and AI. So these are the objective of our study. First, we focus on the jailbreak attack to shift the focus from adversarial attack to jailbreak attacks for the future growth, also to for the future researchers to focus on jailbreak attacks instead of adversarial attack. Second one is comprehensive taxonomy to categorize the diverse type of attacks for better understanding and future research. Third one is the attacks and defense analysis to analyze the operating mechanism of different type of jailbreak attack and evaluate their effectiveness against the current defense strategies. And fourth one is current challenges and future action to identify the limitations of current defense attacks, defense systems, and the attacks for future improvements. Let's distinguish jailbreaking from adversarial attack. So jailbreaking are a specialized form of adversarial attack. The goal isn't just to make model crash, but to bypass the safety filter intentionally to produce the harmful output. We see three key mechanisms here: prompt injection, evasion attacks, and data poisoning. So what prompt injection is, it tells the model to ignore previous instruction, which is already done to the model by the model makers or the creators of that model who have just trained that model for the for maintaining the ethical standards and guidelines. But we just do some manipulation in the prompts to ignore all these rules and instruction which is already fed in the model. In evasion attacks, we exploit the weak mechanism. We just find out what is the weakness of this mechanism, how the filters can be bypasses. So in evasion attacks, the hackers uses these weak mechanism to detect, to bypass these filters. And in data poisoning, we create some backdoors during the training. So we train the model again and again with our prompts and inputs and data, and it creates a backdoor in the model itself to bypass all these safety filters. So techniques used with these mechanism is obfuscation, encoding, cross-lingual deception. This is the methodology we have worked. So we first identified some databases like Springer, PRJ, IEEE archive to find all the recent papers, studies related to LLM safety and security. We identified about 185 initial studies. In the screening, we have filtered these results to focus on technical adversarial attacks and defenses, removing general papers on ethics, policy, or non-text AI. This reduced our list to around 92 papers. In eligibility, we selected only the papers that explicitly discussed jailbreak attacks and bypassing safety rules, excluding theoretical papers without concrete examples. So this left us 30 core papers. In the inclusion, the final set of 30 papers are used to build an taxonomy and analyze these defense strategies for this review. This is the taxonomy of jailbreak attacks. So we have divided these jailbreak attack into 6 main attacks: prompt injection, adversarial suffixes and template, multi-turn context, multilingual and code switching, automated and model assisted, encoding and obfuscation. So in prompt injection, this is a direct command to ignore rules and bypass the safety filters from the model. In adversarial suffix, this uses max optimization to find special words after nonsense words that break the model resistance to these attacks. In multi-turn context, this relies on role playing. The user engage with AI in a very long conversation that AI just refuse. AI don't have any idea about what context user is talking about, and it bypasses the filters. In multilingual attacks, this is interesting. It is the safety filters work great in English and some other languages which is it trained, but often fail if you attack in real languages. It is not get trained by the creators or the manufacturer. In automated generation, using one AI to attack another scale, one AI is attacking the another AI. This is an automated type of attack. In encoding, simply hiding text in base 64 code or some special symbols that AI can't read it, or it just bypasses the filter with the help of inject symbol. So these are the jailbreak attack types we have already discussed. These are some defense mechanism we have categorized from all the study we have done. So the first is prompt level and output level filtering. It checks
Excuse
for,
me, sir.
yeah,
Gentle reminder that you have crossed 9 minutes.
yes, ma'am. So these are 3 type of defense mechanism: prompt level and output level filtering, adversarial training, and retrieval augmentation. So basically, these have some challenges like word matching problem. The model learns with the training, but have not resist to the new type of generation attacks. And retrieval augmentation have some lagging issues. So these are some challenges: computational cost, compromise in quality, and adaptive attacks. For the future direction, we have directed the researchers and engaged the researchers for focus on this type of jailbreak attacks instead of adversarial attack. For first, we have future direction, which is context aware defenses. The model should be trained on context. Second is the standardized benchmarks. Some benchmarks should be there for mitigating these type of attack and detecting these attacks. And third one is multi-layered safety, which we have can combine output level filtering, adversarial training, and retrieval augmentation together to mitigate these type of attack. These are the references. Thank you so much.
Kirit Kumar, sir, any questions?
No. Okay, fine.
Thank you, sir.
Yes, thank you, sir. Next, I would like to call Jitesh Kriplani to present his study on consumer buying behavior and challenges faced by textile retailers in the era of e-commerce and digital transformation.
Hello.
Yes, sir.
Hello. Hello. Good morning, ma'am. Morning, ma'am. Morning, sir.
Good morning, sir.
Hey, myself, Jitesh Kriplani. I am student of MBA third sem, DMIHER, Varda. Today, my topic is a study on consumer buying behavior and challenges faced by textile retailers of e-commerce and digital transformation. This research,
Excuse me, sir. Can you please share your screen?
yes, ma'am. Yes, ma'am. Excuse me, ma'am. Please wait 1 minute.
Sure, sir. Jitesh sir, if you are having any technical difficulty, please allow me to call the next presenter till then, and I will call your name later on. Riddhi Bhadoria, ma'am, are you present? I repeat, Riddhi Bhadoria.
Yes, ma'am. Good afternoon.
Yes, ma'am, please present your paper on capital structure strategies, a comparative analysis of Indian and US IT sectors. Ma'am, you are muted.
Yes, ma'am.
Yes, ma'am, we can see your
Good
screen. Please
afternoon,
start
ma'am.
with the
Okay, my name is Riddhi Bhadoria. I am presenting on capital structure strategies comparing Indian and US IT companies. Introduction of the study is capital structure is a major topic in corporate finance since Modigliani and Miller. Key theories include trade-off theory, pecking order theory, and agency theory, highlighting taxes, bankruptcy, cost, and information gaps. Capital structure practices vary across countries and industries due to regulations, institutions, and market forces. Indian firms typically show lower leverage and rely more on internal funds than US companies. The global IT sector provides a unique setting to study capital structure behavior. Indian IT firms are conservative. US IT firms use diverse debt strategies for tax on return benefit. This study compares 2021 to 2024 data of top Indian and US IT firms on explore similarities, difference, and financing determinants. It's simply the recipe of debt and equity a company uses to fund its operations. For over 65 years, economists have studied why companies make this choice. There are three major theories. First is trade-off theory. The trade-off theory uh, explains that companies balance the tax benefit of tax against bankruptcy risk. More debt, more tax saving, but more financial risk. The second is pecking order theory. Companies prefer internal funds first, the debt, then equity. Why? Because raising equity signals uncertainty to markets. The third one is agency theory. Debt discipline. Management, they must pay interest or face bankruptcy. Equity allows more freedom but dilutes ownership. The objectives of the study is to analyze the capital structure policies of the top IT companies in India and the United States, to examine the influence of contextual variables, regulatory environment, market conditions, firm size, profitability on capital structure decisions in the two nations. Two capital patterns, similarities, differences between and US IT firms. To analyze the actual capital structure policies, the companies follow what percentage of their fund comes from debt versus equity. To understand why these differences exist, it is regulations, market conditions, company size, profitability. We examine all three factors. To identify clear patterns, are Indian and US IT fundamentally different or similarity exist? The review of literature is classic theory. Modigliani and Miller and Mayers explain capital structure but don't fully address emerging market factors. Indian firms generally show lower leverage due to regulatory and market structure differences. Past studies is identify profitability, assets, and reform as key capital structure drives in India. Cross-country research highlights institutional differences but lack focus on IT industry financing patterns. IT and Indian and US tech firms rely on equity due to strong cash flows, through US firms use debt more strategically for tax and shareholders' benefit. Comparative academic studies on firm level financial behavior in global tech companies are limited and need deeper exploration. The classical theory of Modigliani, Miller, and Mayers are brilliant, but they were developed in Western markets. They don't fully explain why Indian companies behave so differently. Recent research by Basu, Kaushik, and others shows that Indian firms have lower leverage for good reasons: limited access to debt market, regulated concentrate, market structure differences, historical preference for internal financing. But here was missing in the literature. Most studies focus on traditional industries, manufacturing, banking, retail. Very few deep down into the IT sector specifically, where cash flows are strong, both in rapid and business model are global. That's the gap of our research field. We are the first to systematically compare IT company financing across their two major markets. Scope and limitations of the study. The study is limited to IT and technology sector firms, which may not represent all industries. Reliance on secondary data may introduce reporting or accounting standard differences. The analysis is restricted to a 4-year period, 2021 to 2024. The data analysis and evaluation. The overview of capital structure ratios in Indian IT companies interpretations are: all Indian IT firms have low debt to equity ratios, usually under 0.25, which reflect a strong equity preference for financing. ROE, return on equity levels are good, which TCS and Infosys at the front of the industry. The US IT companies are US US company exhibit more diverse capital structure. Apple and IBM have high DE ratios using debt for strategic purpose. Microsoft and Adobe exhibit moderate D ratios, and Oracle figures are skewed due to accounting irregulations. The Indian companies most have D ratios of just 0.09. This means for every rupees 1 of debt, they have 11 of equity. It's extremely conservative. Even Wipro, the highest is 0.22, still low. But notice the ROE, return on equity, how much profit per rupee of shareholder money. TCS lead 48%, Infosys at 30%. This is excellent performance. They are making huge profit with minimum leverage. Their cash flow is so strong they don't need debt. But US companies are, this is a dramatically difference. Look at Oracle, D ratio is 30.05, Apple is 2.11, and IBM is 2.54. These companies use tons of debt for every dollar of equity. They have 2 to 30 of debt dollar, but watch the ROE, it's lower. Apple only 1.67%, Oracle is 2.67%. Why? Because with such high debt, their equity base shrink and they have paying massive interest. But and this is crucial, they get tax deductions. The math works for them. Microsoft and Adobe show a middle ground. Moderate DE is 0.35 and 0.33, and strong ROE is 36 and 35%. They balance debt smartly. Debt equity pattern is DE ratio is mostly 40%. Mostly Indian IT companies come under this category, indicating conservative financial policies backed by firm cash flow and negotiable requirement for debt funding. Moderate DE ratio is 30%. US companies such as Microsoft and Adobe have moderate leverage, ensuring financial risk with operational flexibility. High DE ratio is 30%. US companies such as Apple and IBM have leverage ratios, taking strategy for tax minimization and shareholder value maximization. The return on equity is strong ROE of 70%. Firms such as TCS, Infosys, Microsoft, and Adobe exhibit high ROE. reflecting high profitability and effective leveraging of shareholder fund. The low ROE is 30%. Apple and IBM exhibit low ROE levels, which could be due to their large equity bases as well as the influence of greater financial leverage. The conclusion of the study is Indian IT firms like Infosys, TCS, Wipro prefer equity financing and show low debt to equity ratios, aligning with pecking order theory. Their conservative approach is due to limited access to debt market and reliance on internal funds. US IT firms like Apple, IBM, Microsoft use varied capital structures, with some using debt strategically for tax saving and shareholder return. Microsoft and Adobe show a balanced approach, reflecting trade off theory. Differences are influenced by corporate governance, market maturity, and institutional setting. The study suggests future research should explore the impact of ESG, digitalization, and post pandemic market shift on capital structure. And here are some references. Thank you.
Sir, any questions?
No, okay, fine.
Yes, thank you, sir. Thank you, ma'am. Now, next, I would like to call Shika Maheshwari, ma'am, to present her paper on reimagining AI for online education in India, a practitioner's perspective.
Thank you, Dimai, ma'am.
Jitendra, I will be calling for your presentation after this one.
Thank you for considering the request. I hope that my screen is now about to be present. Is it visible? Can I get any confirmation, please?
Yes, ma'am.
Yeah, thank you. So this side, Maheshwari, and sorry, yeah, now it is visible. So here we are going to present our insights from the research paper titled Reimagining AI for Online Education in India, a Practitioner's Perspective. This work is grounded in real, hands-on experience of implementing AI tools in online higher education. The intent is not to glorify technology, but to critically examine how AI is actually functioning on the ground. We explore what is working, what is not, and what needs to be changed for India's diverse education ecosystem. If I'll talk about the background, India is witnessing a major transformation in education due to rapid digitalization. Here we have improved internet connectivity and smartphone penetration, which have expanded access to, the online learning these days. The COVID-19 pandemic accelerated this transition almost overnight. While online education ensured continuity, it also revealed deep gaps. And these gaps exist in infrastructure, in pedagogy, even in the learner engagement. Sometimes the gap has been noticed. And yes, the assessment practices are still, not up to that mark. Coming to the next slide, which talks about the role of AI in online education, the artificial intelligence or AI actually offers solutions to many persistent challenges in online education. AI enables personalized learning paths based on learner behavior, their performances. It even supports the real-time feedback, early identification of learning gaps, and predictive analytics. So we can say that when AI is used responsibly, it can improve learning outcomes while supporting the large-scale delivery. As far as the policy context is there, India has a strong policy push towards technology-enabled education. The National Education Policy NEP 2020 explicitly encourages the use of AI and digital platforms. National initiatives such as SWAYAM, NPTEL, Diksha, all are actually aimed to democratize the access. However, we can say the challenge lies in translating the policy intent into an actual, or you can say into an effective practice. Coming to my next slide, which talks about the literature insights, both the global as well as the Indian research consistently highlights AI's potential in education. Like we are having the intelligent tutoring systems and learning analytics, which are actually improving the learner engagement and even focusing on their performances these days. However, the literature also raises the serious ethical concerns which are, yes, associated with the AI. And sometimes the issues such as data privacy, algorithmic biases, and transparency remains unsolved. Even if we are having certain, some support, but still such type of issues are still required more of the attention. Coming to my methodology framework, though we are having the UGC 4-quadrant model, what we have implemented as per the requirement for online education, as for the compliances. So this model actually includes the content, video lectures, discussion forums, and assessment. So contents and video are meant for the learning purpose, where we encourage our learners to come to the discussion forum in case if they are having any query. Not only that, if there is any something that like they know and they want to share it with their peers. For that purpose also, we invite them for the discussion forum. Assessment is very critical because for every unit, for every, you can say the module, before they move forward, there must be some assessment what we have think that is going to help them. Because before moving to the next module or next unit, where the current standing for the particular unit is something that is required. However, even after having such type of this 4-quadrant module, the standardization is ensured though, but it often becomes the compliance driven. The pedagogical intent is frequently lost during the implementations most of the times. That has been observed during the study. As far as the instructional design challenges are concerned, most online courses are simply digitized classroom syllabi. They actually rely on text, on recorded lectures only. The interactive, the adaptive elements are entirely missing. Even the course coordinator or let's say the faculty members, they often lack training in instructional design. And see, in that scenario, the AI-enabled pedagogy is something that is still new for them. The digital divide remains a major barrier as we have identified. Here, the learner with the urban background or let's say semi-urban background are not having any issue related to the bandwidth or related to any of the devices. They don't have any device limitations also. The courses depend excessively on these video lectures because still we are focusing on the visual learning. And accessibility features such as captions, transcripts, multilingual support are often absent in most of these online courses that has been studied. Apart from that, the poor LMS integration, the learning management system is not capable enough to fulfill all the requirements as mentioned by the learner. Coming to the next is about the discussion forum challenge. Though it is a good practice where we are asking our learners to raise the queries, where we are asking them to even reply, even if they know answer for the queries raised by their peer. However, we can say at this moment that the discussion forums are actually meant to support the peer learning, but in reality, the participation remains very low. Even if there is any synchronous mode of discussion forum, the participation is seen almost none. Because learners hesitate, they are having the fear of judgment and they are obviously lacking the confidence. Yeah, sometimes apart from these challenges from the learner's end, the faculty moderation skills and even the assessment linkage are also limited. Coming to another important challenges that has been identified is the assessment challenge. See, we are having a continuous assessment for whatever the model that we have implemented for our online education. So you can see that most of the online assessments rely largely on multiple choice questions because the descriptive questions actually demand a full-fledged setup to take the examination, and which is not possible even for the small organizations which don't want to invest much in the assessment part also. The limits evaluation to lower order cognitive skills only. The high order thinking such as questions related to create, to develop, analysis, that are really assessed. Even if it is a technical course, such type of things are missing. Apart from that, AI-based proctoring also raises concerns around privacy and the trust. We have also seen the learner support challenges, and this is one of the weakest area of online education as identified. High dropout rates indicate the lack of motivation and mentoring. Most learners study in isolation, where we can say that the collaboration generally help in exchange of knowledge, but still the isolation studies are opted by most of these online learners. Engagement strategies like gamifications, predictive analytics are underutilized even in the urban area learners.
Ma'am,
Not only
gentle
this,
reminder that you have
yes,
crossed
yes,
9-minute
yes,
mark.
yes, yes. The governance challenges has also been identified, looking to the compliance-focused frameworks, limited innovations, and unclear edtech regulations. If we talk about the AI readiness and the challenges, the infrastructure gaps, high cost of AI tools, faculty resistance, and data privacy concerns are something that has been observed very, commonly in all of online courses. Now, if I'll talk about the practitioners' experiences, so the practical implementation of AI showed the positive outcomes. Chatbots improved the learner queries resolution. Adaptive assessments enhance the learner performances. And yes, the faculty acceptance is also improved after this structured training and analytics support. Coming to the next, that is about the future of AI in online education. Yes, that is going to be supported with the help of micro credentials and flexible learning, along with the implementation of virtual labs and simulations, AI driven recommendations to choose the courses, and yes, support for the faculty members as mentor is also required. These are the recommendations from our end. A national AI in education framework is urgently needed. Innovation Sandbox should support experimentations. Faculty development must include AI literacy and ethics. Robust data governance is essential to build the trust. Coming to the conclusion, which is also the last slide of this presentation, AI should complement, not replace the human teaching. Its implementation must be inclusive, ethical, and context aware. And balanced integration of policy, pedagogy, and technology is a key for upcoming time. With the right approach, yes, we can say that AI can transform online education in India. So with this, I end my presentation on the topic, and please let me know if you are having any query.
Yes, Kirit Kumar, sir.
Yeah,
Any questions for
hello.
ma'am?
Hello, ma'am.
Yes, sir.
So, my simple question is, are you now working with any AI-based the tool or platform in teaching learning?
Yes, sir. So we are actually experimenting with some of the AI tools, and these are actually not like supported by the EdTech, but it is an in-house development. So generally, I am associated with the online education vertical of Manipal University, Jaipur, and that's the reason that we have a good number of learners where we can experiment with the AI tools. We are trying to study that what learner needs, how we can cater their needs, and how the faculty can support with the help of AI. Still, I'm in emphasis that the AI is not a replacement; it is just for the support purpose. So yes, sir, we are experimenting it for some of the in-house developed AI tools for making our learner engagement a better one, for making the lifelong experience of learners a better. I hope I have answered your query, sir.
Yeah. Thank you, ma'am.
Thank you, sir. Thanks a
Okay.
lot.
Yes, thank you, ma'am.
Thank you, Dimai ma'am, for taking my request. Thanks a lot for the support.
Thank you. Next, I would like to call Jitesh Kriplani to present a study on consumer buying behavior and challenges faced by textile retailers in the era of e-commerce and digital transformation. Jitesh, sir, are you able to screen share now?
Hello.
Hello, sir.
Yes.
Sir, am I audible to you?
Yes, ma'am. Just wait a minute, ma'am.
Sure, sir.
Yes, ma'am. It is in. Ma'am, is it visible to you?
Yes, sir, we can see your presentation.
Good afternoon, ma'am. My name is Julius Kriplani. I am a student of MBA third SEM, Datta College of Institute, Varda. This research focuses on how digital transformation and e-commerce are reshaping consumer behavior in the textile industry and the and and the challenges traditional textile retailers faced in adapting these challenges. Abstract. The rapid expansion of online shopping platform has significantly increased impulse buying behavior among the consumer. Psychological triggers such as emotions, promotion offers, website design, and social influence plays a crucial role in impulsive online purchases. To begin with this study, examine the rapid growth of online shopping and how it has influenced the consumer buying behavior, especially the impulse buying. Factors such as emotions, promotional offers, website design, and social influence plays a major role in shaping the purchase online decisions. This study uses primary data collected through a structured questionnaire which was analyzed using statistical tools. Primary data were collected with the help of questionnaire. These findings provide insights into how online retailers can influence consumer behavior and how consumers can behave more aware of impulsive purchasing tendencies. Introduction. E-commerce and digital technology have deeply changed consumer behavior in the textile industry. Online platforms offer personalization, convenience, accessibility, shifting buying patterns from physical to digital, which is also known as omnichannel. Consumer now access product information, reviews, and more choices instantly online. Consumer today relies on reviews, social media, and digital promotions while making their purchase decision. Research explore key drivers of consumer choices in textile shopping and evolving digital habits. COVID-19 accelerated digital adoption, pushing retailers towards e-marketing and better online experience. Factors like sustainability, brand trust, and social media now strongly influence consumer decisions. It also studies challenges faced by retailers in digital age. Objectives to investigate the determinants of consumer choice in textile buying with emphasis of the role, price, fashion, and sustainability in the customer shaping choice. Second, to analyze the impact of monthly income of consumer buying behavior, particularly in relation to online shopping, trust in online stores, promotions, and social media advertising. Third, to identify the major challenges that are faced by traditional textile retailers, including the operational cost, competition from e-commerce platforms, and lack of e-marketing knowledges. Finally, to explore the relationship between digital marketing limitations and retailer performance in the presence of social media influence. Review of literature. Digital tools like data analytics help businesses understand consumer preferences and personalized settings. Traditional textile retailers face challenges like high technology, high cost, lack of digital skills, and resistance to change. Interactive technologies can improve online textile shopping by reducing sensory gaps and increasing engagement. Sustainability, brand trust, and consumer behavior are becoming critical in digital retail strategies. Studies also suggest that interactive technologies can reduce the sensory gap in online textile shopping by enhancing customer engagement. The concept of phygital model, which combines physical and digital experiences, is seen as an effective strategy for meeting modern consumer expectation. Hypothesis. Price, fashion trends, and sustainability significantly with price and fashion trends begin the dominant factors. There is a significant difference across income groups in consumer buying patterns for textile, with higher income groups showing a greater preference for online shopping, discounts, and social media advertisements. There are significant differences in buying behavior across income groups, with higher income groups consumers showing greater preference for online shopping, discounts, and social media advertisement. Third, the lack of digital marketing knowledge and social media influence significantly affect the performance of local textile retailers, especially in the competition with e-commerce platforms. Data analysis and evaluation. Data analysis study used SPSS with descriptive stats for demographics and inferential methods, correlation, regression to test hypotheses. Respondent profile. Majority of the population was female, postgraduates, and salaried employees and earned below 25 hours a month. Shopping behavior. Over 55% bought textile monthly, 65% preferred both online and offline shopping. Fashion trends, discount, and experience were the strongest influencing factors. Income level influenced trust in online quality and sensitivity to discounts, but not the preference for physical versus online stores. Digital gap. Lack of digital marketing skills is strongly linked to challenges from e-commerce and fast fashion trends. Traditional retailers reported high operational costs, rapidly changing consumer preferences, their choices, their taste, and competition from fast fashion and e-commerce platforms. Conclusion, e-commerce and digital marketing limitations significantly affect the local textile retailers' performance. Findings. The study revealed several key findings, insights into consumer buying behavior, and the challenges faced by textile retailers in the digital era. Fashion trends and discounts were the most influential factors that driving textile purchases, followed closely by store ambience, customer service, and price. Despite the rise of e-commerce, physical stores remain important in indicating the continued value in store experience. A majority of consumers preferred an omnichannel approach using both offline and online platforms. Income level significantly influenced shopping frequency, trust in online stores, responsiveness to digital promotions. Traditional textile retailers face strong pressure due to limited digital literacy, rising competition, and the need for technological investment. Conclusion. Study highlights the evolving nature of textile consumer behavior amidst the digital transformation. While the consumers are increasingly influenced by fashion, trends, discounts, digital channels, and the tactile and experiential elements of in-store shopping continue to hold value. The rise of e-commerce have not fully replaced, but instead fostered a hybrid or omnichannel model where online and offline experiences coexist. The future of textile is in integrated omni-channel model where online and offline channel both coexist together and help the customer to set their business. The retailers must invest in digital tools, improve online brand trust, and understand the expectation of digitally aware consumers to remain competitive. The income level plays a crucial role in shaping online purchasing behavior, especially in terms of trust and purchase frequency. While the digital platforms influence consumer through fashion trends, promotion, convenience, and physical stores, they still hold value to the tactile and experiential benefits. And these are some references.
Dr. Kirit Kumar, any questions for him?
Thank you.
No, thank you.
Thank you, Jitesh sir.
Okay, ma'am.
Next, I would like to call Vidhi Savjani to present a study on evaluating India's participation in carbon markets for climate mitigation.
Yes, ma'am. Good afternoon, everyone. I am audible to you.
Yes, ma'am.
Okay. Good afternoon, everyone. My name is Ani, and today my research paper on evaluating India's carbon markets for climate mitigation. As
Ma'am,
we
can you
all
please
know
start
that
with slide 1?
climate yes, ma'am.
Can you please start with slide 1? We could see your literature review. I believe Vidhi ma'am has some technical error right now. Let us wait for half a minute or else I will call the next presenter. Vidhi ma'am, can you hear us?
Yes, ma'am.
Yes, ma'am, please share your screen again and start with the presentation.
The screen is visible, ma'am.
Not yet. Yes, ma'am, we
Ma'am,
can
it
see your
is
screen now.
visible.
Yes, ma'am, please start.
Okay, ma'am. Good afternoon, ma'am. My name is Vidhi Saujani. Today I am presenting my research paper on evaluating India's carbon market for climate mitigation. As we all know that climate changes is no longer a distance for a future concern. It is something we are already experiencing in our daily lives. Countries across the world are trying to find solution that protects environment without slowing economic growth. Such market climate based on this solution in the carbon market, which I discuss in the detail. So, if global climate changes are there, rising GHG concentration, human impact, and global priority. As in GHG concentration, where climate change has become one of the most serious global challenge in the 21st century, as we are witnessing rising global temperature, frequent heat waves, floods, and drought across the world. These changes are affecting agriculture, water availability, and human health. Scientific evidence clearly show that the Earth's climate system is under immense stress. Therefore, immediate and effective climate mitigation strategies are required. So, the greenhouse effect gas such as carbon dioxide, methane, nitrogen oxide, and increasing rapidly in the atmosphere. These gas trap heat and create a greenhouse effect which leads to a global warming. And carbon dioxide from burning fossil fuels is the largest contributor to the problem. Industrial activities and transportation also play a significant role. It means continues at this pace, climates will become even more so. In human impact, human activities are the primary drivers of the climate change today. This excessive use of fossil fuels, deforestation, and rapid industrialization have distributed the natural balance. As a result, we can see melting glaciers, rising sea levels, and extreme weather events. This effect impacts threaten biodiversity as well as human settlements. Hence, reducing human-induced emission has a global priority. In the global priority to address climate change, countries have become together through international agreements. The Kyoto Protocol remains the first market Latter is emphasize limiting global temperature rise below 2 degrees Celsius. Carbon markets are promoted as a cost-effective tools to reduce emissions. They encourage industries to adopt cleaner and greener technology. In India's role in carbon markets, India is the third largest emitter of carbon dioxide globally. However, India is also actively committed to climate action and sustainable development. The country has set ambitious targets for renewable energy expansion. India recognizes carbon market as an opportunity rather than a burden. Though this markets India can balance development needs with environmental responsibility. The research objectives. The main objective of the study to understand how the carbon operates in India. It also examines their impact on emission reduction and sustainable development. First, as in the carbon market function, that how to study a carbon market operates in India. Second one is economic and environmental impact, in which to compare the effects of credit trading on India's economic environment. And third, that is obstacle and advantage, to understand the major challenge and benefits of India's participation in national and global carbon markets. Another goal is to identify the challenge faced in the implementation, to study and analyze real India way to the effectiveness market. The importance of the market gains. However, point to regulate gaps in policy, equality, and flexibility has remained made, and lack of awareness to affect participation. These findings are based on the present approach. As here is a case study,
Hello, Vidhi ma'am. I'm assuming she had a technical glitch again. I request everyone to wait half a minute before I call the next presenter. Vidhi ma'am, am I audible to you? Okay, I will be calling the next presenter till then. Henil Mangukia. Henil sir, are you present with us?
Yes, ma'am.
Yes, sir. Please present your study on Kafka-powered, Grafana-driven livestock market insights at a glance.
Yes. Mhm. Is my screen visible, ma'am?
Yes, sir.
Okay. So, good afternoon to the respected session chair, honorable reviewers, and the fellow researchers. I am Anil Mangukia, and I am pleased to present a research paper titled Kafka Powered Grafana Driven Livestock Market Insight at a Glance, that is submitted under the paper ID of 132 at the 10th International Conference on Information and Communication Technology for Competitive Strategies, ICTCS 2025. This work was carried out under the guidance of the Professor Jalpesh Vasa from Charles University, along with the collaboration of my co-author Dick Patel, whose support and insight are very helpful throughout the research. So, here is my structure of the presentation. I will begin with the introduction and the motivation, followed by the objective and literature review. Then I will explain the proposed solution, system design, and the workflow. And at the end, I will end the presentation with the conclusion, future work, and references. So, for the introduction, we note that in the finance market, money matters the most, especially when it comes to the stock market. In stock market, any small delay can result in the significant or the big financial loss. So the problem with the traditional based systems are that they are small, they are slow, and they have a high latency. So we need a system that is quick and scalable. So our motivation is to overcome the problems like delay stock updates, slow based processing, and also high infrastructure cost. We propose a real-time streaming platform for live stock insight using InfluxDB and Grafana. And our goal is to provide instant real-time stock analysis for all users. And our objective is to build a real-time stock analysis platform that stream the data using Apache Kafka, store the data in the InfluxDB, and also interactive dashboard that is from Grafana. And also a user has a feature of dynamic stock selection in real time that ensure high speed, accuracy, and reliability. So this is the literature survey that I had done, and here are some similarities and differences that I noticed. First, from Deepa Lakshmi R, Harsini, and Niveda, that our both research use Apache Kafka for real-time stock, but their focus is on the prediction model, not for the dashboard visualization. Another is from Lopez MA. Similarities compares the real-time streaming platform like Kafka, RabbitMQ, Redis. Their focus is on a performance benchmarking, not end-to-end pipelines. Then Muhammad Ayu Nasir that supports scalable stream processing ideas aligned with the Kafka. But the difference is they discuss on the load balance, not end-to-end visualization pipeline. Then we have Xinwin Zaho that provides strong foundation for understanding streaming and processing system. But the difference is they have a broad taxonomy, less focus on the stock market and the real-time dashboard. And the last is a Kachev and Suring S. Similarity between him research and our research is discuss opportunities in digital analytics aligning with real-time data. And the difference is the research is not related to streaming data or the Kafka architecture. So the proposed solution that our system provide a real-time user-friendly stock monitoring platform by enabling fast data streaming and instant visualization with some following features. First is a live data streaming that is done using Kafka. Then also user has options of dynamic stock selection. Then we have real-time dashboards for price and trend. Auto refresh, user can set his auto refresh. Then accurate up-to-date stock insights. It is a lightweight, low-cost architecture and very clean and the simple UI. So this is the system architecture. For the front-end side, we had used Grafana for the dashboard. Backend side, we use Python-based Kafka producer and the consumer. And for the database, we are using InfluxDB. And our system rely on the three-tier architecture. User interface layer, business logic layer, and the data management layer. So for user interface layer, it will use the Grafana dashboard for the real-time stock and the live charts and dynamic filters. For the business logic layer, stock data stream through Kafka producer and consumer for real time. Also in this layer, the data transformation and the data cleaning steps happen. And for the data management layer, we use InfluxDB to store and retrieve stock data for instant visualization. This is the algorithm workflow that use in our platform. First figure shown the flow chart that I explained. First, user sees the dashboard and user select a stock filter. If user selected it, then Grafana send request to the Google Finance API or the Finum API. Now, in between any kind of error occurs, so it redirected to the user dashboard. Otherwise, user otherwise Kafka get the data from the API, Google Finance API, stores data in the InfluxDB, and again any kind of error occurs, it will redirect it to the user dashboard. Otherwise, Grafana fetch the data from the InfluxDB and update the dashboard. And this is the system flow diagram that fetch the data from the FinHub API and the Google Finance API. Then Kafka producer will produce the data to the broker. The broker manages the data. Consumer get the data from the broker store. InfluxDB store the data from the consumer, and at the last, Grafana fetch the data from the InfluxDB and shows the visualization. Now, here are some system outcomes. The figure is shown is the dashboard of the Grafana, where user can select any kind of KPI and choose a filter. These are some examples. First is a stock filter interface, where you can see a timestamp filter on the upper right side corner in the first image, and also a refresh rate that user want to set. In the figure 5, it's a figure of InfluxDB where the data actually stored. It's a UI, it's a very nice or a unique UI. Also, InfluxDB is known to store time series visualization. Then these are some of the KPIs, starting from the previous close prices that the stock prices have, and the total market capture of the stocks, and also a day high of all stocks. And in the figure, we show that the Meta has a highest price is a 716. So in the conclusion, our platform provide instant and real-time stock insights, reduces delay and manual data handling, and also ensure fast and low-cost market analysis. This project leverages the real-time streaming and transformation stock market monitoring. And this is the future work that we will looking to integrate ML-based price prediction model. Also, we will add a real-time alert for the price spike and drops, introduce anomaly detection for unusual market movements, and also add user feedback and customization for dashboard layout. These are the references that I use. Thank you. Any questions?
Sir, any questions for him? All right, thank you, sir, for your presentation.
Thank you.
Next, I would call Suruchi Pandey to present a study on learning management systems and industry perspective. This presentation will be given by the co-author, Sthita Prajna.
Hi, is my screen visible?
Yes, ma'am.
Yes. Good afternoon, everyone, respected chair, presenters, and fellow researchers. I'm Sthatya Pragya, presenting this paper on behalf of my co-author Suruchi Pandey. Our paper titled Learning Management Systems and Industry Perspective focuses on the usability, stakeholder expectations, challenges, and future direction based on both literature review and primary industry data. Okay, one second. Okay, so the literature establishes learning management systems as a foundational element of modern organizational learning ecosystems. Prior studies consistently shows that LMS platforms enable scalable, flexible, and continuous learning, particularly in geographically dispersed and growing organizations. Research positions LMS platforms as centralized knowledge repository that supports organizational learning and knowledge retentions while also highlighting a clear shift from traditional instructor-led learning to digital and blended learning models. Recent industry literature further describes LMS as front end of learning, requiring back-end support systems such as LearnOps. Market projections reinforce this trend, indicating a strong growth driven by AI-enabled and cloud-based LMS adoption. Now, the literature identifies several benefits of LMS adoption, including centralized content management, flexible access to learning, irrespective of time and location, structured onboarding and compliance training, cost effective delivery of learning programs. Now, the advantages support organizational standardization and scalability. At the same time, there are some key challenges that are highlighted. Studies reported low user adoption, often linked to limited engagement and relevance. The restricted customization, a generational digital divide, high implementation and maintenance cost further impact the long-term LMS effectiveness across the industries. Now, the study overview here, based on these gaps that we have identified, the study was designed to examine LMS from multiple stakeholder perspectives, including users, LMS designers, and learning development leaders. The study also aimed to gather stakeholder feedback to evaluate inclusivity, relevance, and industry alignment of current LMS platforms used in the industry. Finally, it seeks to suggest some improvements that can enable LMS systems to evolve in response to organizational growth, technological change, and workforce expectations. So the primary data here, based on the designer and L&D expert views that we have collected, the insights from LMS designers show that the technology analyst also indicated that the modern LMS platforms must focus on scalability, system integration, analytic driven insights. The API based integration with systems such as HRMS or ERP was emphasized as essential for seamless data flow. However, the challenges such as data synchronization issues and limited effectiveness of AI based content recommendation remain. From the L&D leaders perspective, LMS platforms are effective for tracking learning and supporting upskilling, but concerns were raised regarding the lack of industry specific content and competency alignment in the standard learning management system solutions. Now, based on the user perspectives, which highlight the practical usability of LMS platforms, user value the flexibility and accessibility of LMS, particularly the ability to learn anytime from any location. However, users also report some limitations related to personalization, as already mentioned. Role based learning paths, alignment with career progression in the organization are some of the other concerns. In technical and manufacturing context, the absence of simulation, applied learning reduce the perceived effectiveness in the industry. These insights suggest that user expectations are shifting from contextual and career linked learning experiences. Now, based on these data, we have the key findings. By integrating the insights from literature and the primary data that has been collected for the study, uh, the findings are LMS adoption is steadily increasing across the industries. Through personalization, remain a limitation of the whole study. Now, the findings also emphasize the important role of HR and L&D functions as intermediaries between LMS developers and users, ensuring that the alignment between system design and learner needs to be there. Most importantly, the study highlights the need for LMS platforms to evolve from content delivery tools to talent transformation systems. In conclusion, the study demonstrates that learning management systems have been very essential infrastructures supporting modern learning and development functions. LMS platforms enable integrated management of learning across the employee lifecycle and supported some informed decision making through data and analytics. To remain relevant, these LMS platforms must continuously evolve, incorporating the AI driven personalization, competency based learning paths, deeper system integration, etc. The organization that invest in intelligent and adaptive LMS solutions are better positioned to build future ready workforce and sustain long term competitive advantage. Apart from this, the necessary usage of gamification, AR VR simulation, and chatbots, and already existing the micro learning modules is the need of the hour. With these are some of the references that has been used for this study, and thank you for the opportunity.
Dr. Kirit Kumar, any questions for ma'am? All right, thank you, Sita ma'am, for your presentation.
Thanks a lot, Dimai.
Now, next, I would like to call Divyesh Bhatnagar to present his study on performance enhancement in blockchain technology through database sharding.
Hello, am I audible?
Hello, sir. Yes.
Uh, just a minute. My screen is visible to you.
Yes, sir.
Good afternoon. I am Divyesh Bhatnagar, research scholar from MBM University, Jaipur, and another author is with me, my guide, Dr. Anil Gupta, as my paper topic is performance enhancement in blockchain technology through the database sharding. Now, the first slide is this presentation is about the improving blockchain performance using database sharding. Blockchain starts with Bitcoin, but is now used in the area like banking, healthcare, and voting. The main issue is that the traditional blockchain are secure and transparent, but suffer from the low throughput, high latency, and the high resource usage. Sharding is the proposed as a way to scale performance while keeping decentralization and the security. Now move to the next slide. Basics of blockchain. Blockchain is a distributed ledger where data is grouped into blocks, linked users, cryptographic hashes, and replicated across all the nodes. There is no central authority. Instead, many independent nodes maintain validate the ledger. Key properties and the decentralization, transparency, immutability, and the pseudonymity, which makes it hard to tamper with data and easy to audit transactions. Now move to the next slide, that is distributed ledger and the architecture. Distributed ledger technology means the database is shared and updated across many nodes, improving reliability and removing intermediaries. Blockchain architecture can be seen in layers, the logical layer with assets and smart contracts, the physical layer with transaction blockchain and the ledger, and the access processing layers that handle how data is read, written, and the kept consistency instead of strict ACID properties like in the traditional database. Blockchain often aim for transparency, immutability, and eventually consistency. Now, next slide is consensus and the security issues. To keep the ledger consistent, and the blockchain uses consensus mechanism. Examples including proof of work, where miners solve the puzzles, proof of stake, where validators stake points, and the Byzantine fire tolerance variant that tolerate faulty or the malicious node. However, several security challenges remain. 51% attack, where an attacker gains the majority controls, private key compromises, and double spending, and the criminal uses such as money laundering due to anonymity. Now the next slide is stability problem in the existing system. In the existing system, every node stores and validates almost all transactions, which leads to heavy storage bandwidth and the computation overhead. As the network grows, the diameter increases, synchronizations become harder, and the complex protocols are needed to resolve conflicts. This results in the low throughput, higher confirmation time, and the difficulty in scaling to large number of users and transactions. Now move to the next slide. The motivations for the sharding. Consensus algorithm helps secure blockchain of but often increases energy and the computation cost. Proof of work is especially energy investive and the large stakeholder. Proof of stake concentrates power with the large holders. There is a clear need for a method that can increase transactions per second and reduce per node resources requirement without centralizing the system. This motivates the users of database sharding inside the blockchain architecture. Now, what is the database sharding? Database sharding means splitting a large database into a smaller independent part called shards. Each shards hold a subset of the total data and can be stored and processed by different nodes. This reduces the storage and the computation burden on any single nodes, improve availability, and can speed up access. Since the query or the transaction only touch the relevant shards instead of entire global dataset. Next slide is sharding applied to the blockchain. When sharding is applied to the blockchain, not every node need to maintain the full ledger. Different shards handle different set of accounts or the transaction. This allows transaction to be processed in the parallel across shards, increasing over throughput. At the same time, the system remains distributed because multiple validators operate within each shard instead of relying on a central server. Now, next slide is showing the performance enhancement points. Sharding directly address performance. Since multiple shards can commit blocks at the same time, the effective transaction per second of the entire network increases. Then each node in the shard handle a smaller state and the fewer transactions, which reduces CPU memory and network overhead. This also can reduce latency because blocks within a shard can be produced and validate faster than in the fully replicated globally blockchain. Now, what are the security issues and design considerations? Shards also bring challenges, especially for the security. Cross-shard communication must be designed carefully to prevent inconsistent state or cross-shard double spends. There is also the risk that an attacker may try to control a single shard instead of the whole network. Therefore, validator assignment and the consensus rules inside the shards must ensure that no shard can be easily captured and that the global view remains constant and secure. Now, the future work which I have proposed in my paper is that the paper suggests that the future work should include the implementation sharding in the blockchain prototype and testing them with the realistic workload. It also highlights the need of steady trade-offs between security, decentralization, and the performance for the different sharding strategies and consensus mechanism. The expectation is that well-designed sharding can significantly improve the availability and scalability without sacrificing the core guarantees of the blockchain. Now, last is the conclusion. To conclude, the blockchain provides a strong foundation for secure decentralization application, but current system face serious performance and the scalability limits. Database sharding is promising solution because it divides the global state into a smaller parts, enabling parallel processing and reduce resource uses per nodes. If implemented properly, sharding can make blockchain more practical for the large-scale application beyond cryptocurrencies, such as finance, healthcare, and e-governance. That's all from my side. Thank you.
Kirit sir, any questions? All right, thank you, Devesh sir, for your presentation.
Thank you, ma'am.
Next is Jigyasa Jyoti. Jigyasa ma'am, please present your study on unveiling the unspoken, analyzing depression causes with machine and deep learning.
Am I audible, ma'am?
Yes, ma'am.
Okay. Is it visual?
Yes, ma'am, we can see your Zoom screen.
Good afternoon, ma'am. I'm Siddhyasa Jyoti, and my title is Unveiling the Unspoken Analyzing Depression Causes with Machine and Deep Learning.
Ma'am, can you please share your PPT screen? We can see your Zoom screen right now.
Okay, wait. Is it visible now? Ma'am,
No.
Wait. Ma'am, is it visible now?
Yes, ma'am, we can see it now.
Okay. So, good afternoon, ma'am. I'm Zagyasa, and my paper title is Unveiling the Unspoken, Analyze Interpretation Problems with Machine and Deep Learning Model. This is the overview, the abstract methodology, introduction, problem, objective, result, conclusion, reference. So, abstract depression detection is a challenging task due to its subjective nature. In this study, we apply machine and deep learning models after performing exploratory data analysis and PCA for noise reduction models such as SVM, random forest, CNN, RNN, and LSTM were evaluated using accuracy, precision, recall, F1 score, and AUC ROC curve. The objective is to build a scalable and reliable system that can support mental health professionals in early diagnosis. Introduction. Depression affects more than 280 million people globally, yet many cases remain undiagnosed. Traditional diagnosis methods are time consuming and subjective. Our research proposes a data driven framework using ML and DL models to analyze behavior and emotional cues from data. This approach aims to provide timely, consistent, and scalable support for mental and health diagnosis. Problem statement. Depression is a serious mental health disorder affecting emotions, thoughts, and behavior. Despite medical advancements, many individuals do not receive early or effective diagnosis. Factors such as symptom complexity, social stigma, and lack of resources increase the global burden. Hence, there is a strong need for automated and objective detection systems. Objectives. The main objective of the study are to develop a machine learning and deep learning based framework for early depression detection, to evaluate the system using standard performance metrics to ensure reliability and clinical usefulness. Methodology. We use a Cadle dataset containing 773 instances and 22 features related to demographic, lifestyle, and health indicators. Pre-processing involve handling missing values, normalization, categorical encoding, and smooth to handle data imbalance. EDA techniques such as correlation heat maps and box plot were applied, followed by PCA for dimension reduction. We implemented ML models like SVM, random forest, KNN, deep learning models like RNN and LSTM, and also tested reinforcement learning for enhanced prediction. Result. The performance of all models were evaluated using accuracy, precision, recall, F1 score, and AUC ROC. Random forest achieved the highest accuracy by 94%, followed by SVM with 92.4%. Reinforcement learning also performed comparatively. Deep learning models performed well but were slightly limited due to the small dataset size. Overall, assemble and margin-based classifiers showed superior results. Conclusion. This study demonstrates that the hybrid ML and DL approach can effectively detect depression. Reinforcement learning and deep learning models help reduce false positives and false negatives. However, challenges such as data quality, ethical concerns, and interpretability still exist. Future work will focus on explainable AI and richer database to improve real-world deployments. These are the references. And thank you, ma'am.
Kirit sir, any questions for ma'am? All right, thank you, Jigyasa ma'am, for your presentation. Lastly, I would call Vidhi Savjani to present her paper from where she left off last time due to technical glitch.
Yes, sure, ma'am.
Yes, ma'am. Please start with the slides you left off.
Okay, ma'am. Am I visible, ma'am? Audible, ma'am?
Yes, ma'am.
Okay.
We can see the case study slide, just so you know.
Yes, ma'am. Yes, yes.
Okay.
So here the case study of NTPC Limited. NTPC Limited is NTPC Limited is the India's largest power generation company. It has implemented several clean development mechanism or CDM projects. These projects focus mainly on renewable energy resource. NTPC aim to reduce emissions while maintaining energy security. This makes NTPC an important case study for carbon market analysis. As here are some impacts and challenges of NTPC uh, Limited, as it reduced over 85,000 tons of CO2 annually. It renews from CER reinvented in renewable ventures aligned with India's NCD for the Paris Agreement. And their challenges decrease international price post 2012, unclear rollout plan for Article 9, Article 6 mechanism, complex project registration and verification rule. Now, let's move towards the another case study that is Indian Railway case studies. Here, Indian Railway is one of the largest transport networks in the world. It has several initiatives to reduce its carbon footprints. This includes energy efficiency measures and renewable energy adapt- adaptations. Indian Railway also participates in CDM projects. It sales makes it significant contributor to emission reduction. Here in CDM projects in 2013, Indian Railway initiates CDM projects to reduce greenhouse gas emissions. This project focused on improving energy efficiency across operations. They help in reducing electricity consumption. This project also generated carbon credits. This demonstrated how public sector organized can participate in carbon markets. In LED lighting, one major initiative was the replacement of conventional lighting with LED lights. LED consumes significantly less electricity than traditional bulbs. This results in a lower energy consumption and reduced emission. It also helps in cost saving for Indian railways. Small change like this can have a large environmental impact. In solar power, Indian Railways install solar panels as a station and on trains. Solar energy reduces reliance on fossil fuels. This installation helps in cutting down carbon emissions. They also promote clean and renewable energy usage. Such initiatives align with India's long-term climate goal. The impact and the opportunities in Indian Railways. Indian Railway achieved significant emission reduction through these initiatives. This project improved operational efficiency and sustainability. There is a strong potential for a future participants in a national carbon market. Scaling up these effects can generate more carbon credits. This can further support India's climate commissions. As in the conclusion of the India's market potentials, carbon markets play an important role in climate change mitigations. They provide economic initiatives or reducing emissions. In India, carbon market supports both environmental sustainability and economic growth. Case study shows positive outcomes despite certain challenges. With the proper regulations, carbon markets can be highly effective. As India needs a strong, transparent carbon market policy framework. Technology, innovation, and capacity building are essential. Greater private and public sector participation should be encouraged. Stable carbon pricing can improve market confidence. This step will strengthen India's climate mitigation efforts. Thank you for your attention and patience. I hope this presentation helped you to understand the carbon markets better.
Thank you, Vidhi ma'am, for your presentation. Kirit sir, any questions for her? All right, thank you so much, Vidhi ma'am.
Thank you so much, ma'am.
We are done with all the presentations and we'll move on to the closing remarks. I sincerely thank our authors for their excellent presentations and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for the support during this 10th version and all the previous 9 versions of the conference. We will be happy to have you in the 11th version in 2026. All the presenters would be getting their digital certificates through email within 2 working days. The publication will be live within 7 to 8 months, hence I request everyone to kindly cooperate with the team of ICTCS 2025. I would also like to thank our session chair, Dr. Kirit Modi, for chairing the session. I'm sharing a token of appreciation on behalf of Team ICTCS and Global Knowledge Research Foundation and partners. Thank you for your valuable presence, Kirit sir. And if you have any closing remark for the presenters, please let us know. All right, thank you once again, Kirit sir. Now, before we end this session, I request everyone to please turn on your cameras for a quick snapshot of this virtual conference. All right, thank you everyone. Have a great day ahead. Stay safe. Take care. Thank you.